Hello friends, so today we are going to do the questions from modern physics. Questions are from year 2019 and we are going to solve 4 questions from mains as well as 4 questions from advanced. So in total we are going to solve 8 questions, and for the year 2019 this is part 5th. The first 4 part we only covered the mains question, and this is the last part for the year 2019 in which we are going to solve 4 mains as well as 4 advanced questions. So the first question, it states that in the free space the energy of EM wave in electric field is UE and magnetic field is UB. Then we have to find out the relationship between the electric field and magnetic field energy. And we start with the basic formula which tells us that our electric field energy which is given as UE is equal to half epsilon naught and E square, and similarly magnetic field energy that is our UB is equal to half B square upon mu naught. And we already know the relationship between electric field and magnetic field. We know that electric field is equal to C multiplied by magnetic field, where C is the speed of light, and this C is given as 1 upon mu naught times epsilon naught. So from here we can write our B is equal to E upon C. So we substitute B is equal to E upon C in the equation of our magnetic field energy. So we can say our magnetic field energy, our UB, is equal to half multiplied by 1 upon mu naught, and this comes as electric field divided by C and whole square. And we can also substitute value of C, so this comes as half 1 upon mu naught E square, and this comes as 1 upon mu naught and epsilon naught. Mu naught and epsilon naught cancels out, so this comes as a half epsilon naught E square, and this is nothing but the representation of our electric field energy. Therefore we can say our magnetic field energy is equal to electric field energy. So option A is correct. Next question. We are given an EM wave from air enters a medium. The electric field are E1 governed by this equation in air and E2 governed by another equation in the medium, where the wave number k and the frequency it should be actually nu, not n. So this should be our nu. Refer to their values in air. The medium is non-magnetic if epsilon ER1 and epsilon ER2 refer to relative permittivities of air and medium respectively. Which of the following options is correct? So we are given two different equations of electric field. The first one is for air and second one is given for the medium. And we have to remember that it is given that the medium is non-magnetic. So if the medium is non-magnetic, therefore we can say mu r, that is our relative, is equal to 1. Okay. And we have to find out the relative permittivities relationship. So let us take the equation one by one and try to solve it. Okay. And okay, so let us call this equation number 1 and this is our equation number 2. So we can say let's find out wave number and frequencies. Wave number of frequencies. First let us calculate for air. So you can say for air, and air is basically our equation 1. So for air we can write that our phase, let us call it as a phi 1, will be equal to is 2 pi nu and z upon c minus t. Okay. And this is z. We multiply, we get from here that our phase phi 1 will be equal to 2 pi nu z upon c minus 2 pi nu times t. Therefore we can say that a wave number for the first wave, which we are calling as k1, will be equal to 2 pi nu upon c, and our angular frequency, that is omega, will be equal to 2 pi nu. Okay, so we are able to find out the wave number, phase as well as the angular frequency. And similarly we are going to write for medium. For medium, which is our equation number 2, we can say our phase phi 2 is equal to k2z minus ct, and we multiply, we get our phi 2 is equal to 2kz minus ckT. So from here we get a wave number, that is our k2 is equal to 2 times k, and our frequency is equal to k times c. Let us call this as omega 1 and this is as omega 2. And in this case we have to remember that both are the representation of your same frequency. So you can say, but both are describing same frequency. That is our nu, as, or we can say since the wave is continuous across the boundary, is continuous across the boundary. Therefore, you can write for air we have our omega 1 is equal to 2 pi nu, and they are representing same frequency. So from here we can say omega 1 is equal to omega 2. Therefore, in place of omega 1 we can write omega 2, and omega 2 is equal to our kc. Therefore, we can say k multiplied by c is equal to 2 pi nu, and this gives us that the value of k is equal to 2 pi nu divided by c, and our k2 is twice k. Therefore, we can write k2, which is our twice k. This will be coming as 4 pi nu times c. And for medium, we have our k2 is equal to omega upon v2, and omega already we know is our 2 pi nu upon v2, and we substitute value of k2 as 4 pi nu, so we get this as 4 pi nu upon c is equal to 2 pi nu upon v2. This gives us that our v2 is equal to c upon 2. And now we can easily find out, or we know the relationship between the wave speed and permittivity. Okay. So we can say that a relation between wave speed and permittivity. And the material that is given to us is non-magnetic. So we can say for non-magnetic our wave speed v is equal to c upon epsilon times r, that is our relative. And we can write this will be equal to our c upon, for medium, that is our er2, velocity is our c upon 2. So from here we can say c and c cancel out, square root of relative permittivity is equal to 2, or we can say our er2 is equal to 4. And for air, we know for air the er1 will be equal to 1. Therefore, its ratio er1 upon er2 is equal to 1 upon 4. So we get option number D is correct. Option D is correct. Next question. It states that in the radioactive material, fraction of the active material remaining after time t is 9 upon 16. The fraction that was remaining after t upon time t upon 2 is. So we are given after time t, fraction remaining is 9 upon 16, and we have to find out what fraction will be remaining after time t by 2. So here we are going to use the decay law. And the decay law gives us that after time t, suppose n of t is remaining, that will be equal to our n naught initial amount e raised to power minus lambda times t. And we are given that the fraction remaining after time t is 9.16. Therefore, we can rewrite this equation that remaining amount oblique original initial amount is equal to e raised to power minus lambda t, and this ratio is given to us as 9 upon 16. And okay, and we have to find out the remaining after time t by 2. Okay, so we can just, let me write it separately, e raised to power minus lambda t is equal to 9 upon 16. So if we take square root for both sides, we are going to get, taking square root, we get e raised to power minus lambda t, and this comes as whole 1 by 2, and this comes as 9 upon 16 whole raised to power 1 by 2. And we can write on the our left side will be our e raised to power minus lambda t upon 2 is equal to, this will be coming as 3 by 4. Therefore, we can say, we can rewrite the same decay formula as n t by 2 is equal to our initial amount e raised to power minus lambda t by 2, because we have to find out when time t is equal to t by 2 and the fraction amount remaining. So we can find out the fraction, that is n t by 2 upon n naught is equal to e raised to power minus lambda t upon 2, and right side we know is equal to our 3 by 4. So this comes equal to 3 by 4. So answer number option C is correct. C is correct. Next question. It states that the magnetic field of a plane EM wave is given by this equation, where C is the speed of light, given as 3 × 10⁸ meter per second is the speed of light. The corresponding electric field is. So we have to find out the corresponding electric field and from the magnetic field that is given to us. And here from the given equation, we know that this part is the representation of our B0 and our I unit vector is the representation of our direction. Okay. So we can say, let us call this as equation 1. So from equation 1, we have our B0 is equal to 3 × 10⁻⁻8. And we know the relationship between electric field and magnetic field. Therefore, we can say our E0 is equal to C times magnetic field. So we get this as 3 × 10⁸ multiplied by 3 × 10⁻⁸. This comes as our 9 volt per meter. Okay, so at least we can say that option B and C are incorrect. Okay, only option A or D will be the correct one. Now we are going to find out its direction. Magnitude we found out is 9. Now we are interested in direction of the electric field. Direction of our electric field. And okay, first of all, from the equation number 1, we can say that the wave is propagating along negative y direction because of the argument is our y plus ct. Okay. So we can say that our wave propagates in negative y direction because the argument is y plus ct, and the direction of magnetic field is our I unit vector, or we can say x direction. Magnetic field is in I unit, or we can say x direction, because I unit is already mentioned in the equation itself. So this is the representation of our magnetic field. And we know that our direction of propagation that is our k unit propagation will be equal to our electric field, magnetic field, and our this k unit propagation is our in negative y direction. So this will be our minus of j, our unit vector of our magnetic field is our I unit vector. Therefore, we can write this is equal to over minus of J is equal to electric field unit vector cross I unit vector. So obviously from here we can write that our unit vector or direction of the electric field should be equal to over minus of K unit vector. Okay, so this is the direction of our electric field. So we already found out our magnitude as well as direction. Therefore, we can write our equation, and we know that electric field has the same sinusoidal term that of the magnetic field. You can say our electric field has the same sinusoidal term as the magnetic field. Magnetic field. Therefore, we can write that our electric field will be equal to over E naught sine of 200 y plus Ct, and we have a direction of a unit vector electric field. We substitute the values. So we get electric field is equal to magnitude is 9, and this will be giving us minus of K. So we put here minus. This will be sine of 200 y plus Ct, and here we have our K unit vector. So this is our electric field. So option D is correct. A is incorrect. You can say option D is correct. D is correct. Next question. Next is from 2019 advance, and it states that a free hydrogen atom, after absorbing a photon of wavelength lambda a, gets excited from the state n is equal to 1 to n is equal to 4. Immediately after, the electron jumps to n is equal to m state by emitting a photon of wavelength lambda e. Let the change in the momentum of the atom due to the absorption and the emission are lambda PA and lambda PE respectively. If lambda A upon lambda E is 1 upon 5, which of the options is correct, is or are correct? So here we are given that it absorbs a wavelength lambda A and jumps from n is equal to 1 to n is equal to 4. So this is the first condition that is given to us. So it states that the hydrogen atom, it absorbs a wavelength of lambda A, and this results the transition from N1 to N4. And after that, here we have to remember this lambda A is absorbed. Lambda B absorbed, and it makes a transition from n is equal to 1 to n is equal to 4, and after that it emits the photon. Emits photon, and whose wavelength is given as lambda e, and when the transition it makes from n is equal to 4 to n is equal to m, and the ratio of our this lambda a upon lambda e is also given to us. Lambda a upon lambda e is equal to 1 upon 5. So first of all, it is given that the lambda e is equal to 418 nanometer. Okay. So we are going to find out the energy level or difference in energy, and then we can find out the wavelength. So we can see energy levels of hydrogen. And that formula, that is our E of n is equal to minus 13.6 1 upon n square E electron volt. And first transition is from 1 to 4 and energy is absorbed. Okay. So we can say energy absorbed during the transition from n to 1 to n to 4. And let us suppose that energy is represented as our EA, which will be equal to our E4 minus E1, giving us 13.6 1 upon 4 square, that will be 16 minus 1. And this will be coming as, this will be 15 upon 16 minus and minus minus plus, and this will be coming as 13.6 multiplied by 15 upon 16. So we get energy in the first case, transition from n to 1 to n to 4, it will be approximately equal to 12.75 electron volt. And we can now use the relationship of the energy and wavelength. So from here we can say our lambda A is equal to Hc upon Ea. Hc is said to be 1242, and this is about 12.75, approximately equal to 97.4 nanometer. So we found out our lambda A, and we are given the relationship between our lambda A and lambda E. Therefore we can write that our lambda E is equal to 5 times lambda A, which comes as 5 times 97.4, which will be approximately equal to 487 nanometer. So our wavelength, option A is incorrect. It is given a 418. So you can say option A is incorrect. Next, we try to find out the change in momentum, that is given as 1 by 2. So we have change in momentum due to photon. Change in momentum due to photon, and relationship is a standard one. Momentum P is equal to h upon lambda, or we can say our change in momentum will be proportional to 1 upon lambda. So we can write this as delta PA and delta PE will be equal to 1 upon delta A 1 upon delta E. So we get this change in momentum ratio will be equal to lambda A and lambda E, which is equal to 5. And it says that it is 1 by 2, so which is also incorrect. So we can say option B is incorrect. And next is ratio of the kinetic energy from the transition Nm to N1. So we know the equation for our kinetic energy. We can say that, or let us start with our energy at nth level, which we have already written the formula. We can say energy at nth level, which is our E of n, will be equal to minus 13.6 upon n square electron volt. And from here we can say our kinetic energy will be equal to minus of the En, which gives us 13.6 upon n square electron volt. And it states that the level it moves from is n is equal to m to n to n 1. So therefore from here we can write kinetic energy when value of n is equal to 1 will be equal to our 13.6 electron volt, and kinetic energy when the level is our m is equal to 13.6 upon m square electron volt. And we can find out the ratio. So ratio gives us that kinetic energy m, kinetic energy for the first is equal to, this is about 13.6 upon m square, 13.6. This cancels out, so we get this is equal to 1 upon m square. And one second. Ratio of this is 1 by 4. Okay, and in the option number C, it is given that this ratio is equal to 1 by 4. So from here we can say value of m is equal to 2. Therefore so in this case we have used the option C directly, that assuming that value of this ratio is equal to 1 by 4, which gives us m is equal to 2. So option D is correct. Okay. And for option C, we can say option C is correct if the electron lands at level n is equal to 2, and this is verified from option D. So only C and D option are correct. C and D are correct. Next question. It states that suppose a Ra nucleus at rest in ground state undergoes alpha decay to a Rn nucleus in its excited state. The kinetic energy of the emitted alpha particle is found to be 4.44 mega electron volt. Rn nucleus then goes to its ground state by gamma decay. The energy of the emitted gamma photon is, and various atomic masses are given to us. So in this case, we are going to find out, first of all, use the mass defect, and there from mass defect we are going to find out the Q value. So we can say our mass defect and Q value, and we have this delta M will be equal to mass of Ra is our 22.6005 and mass of our Rn is our 000 and mass of our alpha particle is given as 4.00. This gives us 0.005 U, and from here we can find out the Q value. That is, our Q will be equal to mass defect multiplied by 931.5. This gives us 0.005 multiplied by 931.5, which gives us 4.6575 mega electron volt. And we are also given that the energy of our alpha particle, so we can say our kinetic energy of alpha particle is given to us as 4.44 mega electron volt, and let us say that the kinetic energy of Rn nucleus is K of our Rn. So we can say that the kinetic energy of Rn is given as K of Rn. So we know that momentum is conserved, and therefore we can write momentum is conserved. So we can directly write it as K of our Rn, K of our alpha is equal to mass of alpha and mass of our Rn. So therefore we can write our kinetic energy of Rn molecule will be equal to mass of our, it has to be alpha, and mass of Rn multiplied by energy associated with alpha particle. So this comes as 4 upon 222 multiplied by 4.44, which comes approximately at 0.08 mega electron volt. Now we can just easily find out the energy of our gamma photon. Energy of our gamma photon, and we can say that our total decay energy, which we found out is our Q value. Q is equal to energy associated alpha plus energy associated with Rn plus energy associated with gamma. So we can just rearrange it. We can write energy associated with gamma is equal to Q minus K alpha minus K of our Rn, which gives us 4.6 minus 4.44 minus 0.08. Therefore, we can write that our gamma energy is equal to 135 kilo electron volt. So this is our 135. Next question. It states that a perfect reflecting mirror of mass m mounted on a spring constitutes a spring mass system of angular frequency omega such that 4 pi m omega upon h is 10 raised to the power 24 per meter square, with h is Planck's constant, n number of photons and lambda is wavelength, which is given as 8 pi into 10 to the power minus 6 meter, strikes the mirror simultaneously at normal incidence such that mirror gets displaced by 1 micrometer. The value of n is x into 10 to the power 12, then the value of x is. So in this case, basic figure is given to us. We are having a mirror connected to a spring, and light is strike this mirror at a perpendicularly, and the spring is slightly displaced by a distance of 1 micrometer, and it is given that is a perfectly reflecting mirror. Therefore, we can say for our perfect reflection, momentum transferred per photon will be equal to our 2h upon lambda. So total momentum, if there are it is given that there are there are n photons. So therefore we can write that total momentum let us call this as P total will be equal to n multiplied by 2h divided by lambda. And now this is nothing but a mass, which is a combination of our this photon, and spring is given as massless, so we can consider it as a spring mass SHM. spring mass SHM, and for that we are going to find out what will be the value of our maximum momentum. For that we are going to use the basic equation for our SHM, which gives us that for SHM we have our x of t is equal to a cos of omega t. Here A is the amplitude, omega is the angular frequency, and A is our amplitude, we have our omega as angular frequency, which is also our k upon capital M, and xt is the displacement or instantaneous position. So now we can just find out, based on this position, we can find out the velocity. So we can say our velocity of SHM, which is suppose our v of t, and will be given as derivative of our x, which will be coming as minus a omega sine of omega t. And we know that the velocity will be maximum when sine of omega t will be our maximum, that is equal to plus minus 1. So from here we can say for maximum velocity our sine of omega t is equal to plus minus 1. So we are only interested in the magnitude, therefore we can write that our V max is equal to a times omega. Now we can easily find out the momentum. So we can say here that our momentum in SHM which is our P of t, will be equal to mass multiplied by velocity, or we can say our P max will be equal to mass multiplied by velocity max, which gives us ma times omega. So this is our maximum momentum. So we have two equations for momentum. One is our, let us suppose this is our equation number 1, and this is our equation number 2. So both are the representation of momentum. Therefore we can write equating 1 and 2. We get our 2nh upon lambda is equal to ma omega, and from here we can write that our n is equal to ma omega divided by multiply by lambda and divided by 2h. And we are given that lambda is given to us and the displacement is also given to us, that is 1 micrometer. So we substitute the value. This is equal to, we have here m omega, a is our 10 to the power minus 6, lambda is our 8 pi into 10 to the power minus 6 divided by 2 pi. Here pi, and this goes by 4. Therefore, we get that is of n is equal to 4 pi m omega, and we have here 10 raised to the power minus 12. Here I forgot to write. One second. Oh, sorry. This is not pi but h. This is h and this is pi. Therefore, we get a divided by our h. And in the question, this is already given to us. This value is given as 10 raised to the power 24 multiplied by 10 raised to the power minus 12, which comes as 10 raised to the power 12. And we are given that value of x n is equal to x times 10 raised to the power 12, and we found out this will be 1 into 10 raised to the power 12. Therefore, value of x is equal to 1. So we have value of x is equal to 1. So these were the questions from the year 2019, mains as well as advanced. So this completes all the questions from the year 2019. We did for 2019, we solved the question in 5 parts. First 4 parts were only consisting of mains question, and this part, that is 5th part, were consisting of our mains as well as our advanced questions. So this completes our for the year 2019. Thank you.